Hi, I'm Parker Haynes, and today I'm going to talk about the effect of air on the voltage of a microbial fuel cell. The purpose of the experiment is to create a microbial fuel cell, or MFC, which produces electricity from anaerobic bacteria. The MFC contains pond sludge, which is made up of organic matter and anaerobic bacteria. The anaerobic bacteria breaks down the organic matter and produces two byproducts: hydrogen, which goes across the salt bridge to the second chamber with water, and electrons, which go through the anode, and when the anode and the cathode are connected, it produces voltage. On this side, when the hydrogen is transferred over here, the hydrogen and the oxygen combine to make water. My hypothesis is adding air to the water chamber of a microbial fuel cell will increase the voltage output. My independent variable is the amount of air. My dependent variable is the voltage. I had 3 containers with air and 3 without added air. I tested it over 4 days. My control was the no added air. My constants were the amount of water, the amount of pond sludge, the thickness of the salt bridge, the number of coils, and the containers. My consumable materials were the pond sludge, the water, the copper wire, the yarn, the containers, the RTV silicone, the duct tape, the electrical tape, and the tubing. My equipment was the voltmeter and the air pump. First, I drilled holes in the container for a salt bridge, a coil, and an air pump. Next, I gathered pond sludge. After that, I braided yarn together to make a thin rope. After that, I dissolved as much salt as possible in water. Then I soaked the rope in the salt water to create a salt bridge. After that, I entered the salt bridge in the holes in the container and then sealed them with RTV silicone. After that, I wrapped the salt bridge in duct tape. Next, I coiled the wire around to form 5 coils using 18 inches of copper wire to create the anode and cathode. Next, I filled 1 container with 30 ounces of pond sludge and sealed it with RTV silicone. Then, I filled the other side with 20 ounces of water. Next, I pumped air into the water container once a day for 10 minutes. Finally, using a voltmeter to measure the voltage, I measured the voltage in millivolts each day. As you can see here, the containers with added air were had significantly higher voltages than the ones without added air. According to my experience, the MFC with added air to the water chamber showed an increase in voltage over time to the one without added air. My hypothesis was that adding air to the water chamber will increase the voltage output of my MFC. My results support my hypothesis. The test I performed had minimal air. The one item I could not control is the amount of bacteria in each 30 ounces of sludge. This may account for variability over trials. In future trials, I would try it on a larger scale to see how much voltage I could generate. The project could be applied to supply power to places without community power. It could help power long-term space travel. Think fuel for the future. Thank you.